not going to be working in the unit circle, but let's define what the 6 trigonometric functions are when we're not working in the unit circle. So cosine of theta is equal to x divided by r. Sine of theta equals y divided by r. Tangent of theta equals y divided by x. And the rest, to get the other ones, you can flip. These are the only ones you really have to know. The other ones you can flip, but cosecant of theta equals r divided by y. Secant of theta equals r divided by x. Cotangent of theta equals x divided by y. When you're in the unit circle, this is how it looks like. But usually when we're talking in a unit circle, we don't include r. We just do cosine equals x. Tangent and cotangent are the same regardless. But cosine, sine, cosecant, and secant, usually cosecant is written, when we're talking about the radius of 1, which is the unit circle, is 1 over sine of theta. It's the same thing here because the unit circle its radius is 1. So if we wrote cosine of theta equals x divided by 1, it's just x. So that's why we don't include it. So yeah, so now what I want to work with is how can we evaluate trig functions given our x and y terminal points? How can we find out where we are? And what our cosine, sine, we can get all of these trigonometric functions from. And keep in mind that theta is just an unknown angle, but for this problem specifically, we're willing to know what theta is. We can just use the ratios and solve for what they want. So now we can apply the functions we just listed, and we can find out at theta what are our trigonometric values. So here this problem says find the values of trigonometric functions at theta. So theta is just a placeholder for an angle. So we have to use our ratios. So what do? So we have an x value and we have a y value. These are our terminal points. They're given. Terminal points of our theta, of our angle, unknown angle. And we have to find the values of the six trigonometric functions at theta. So how do we do this? Well, recall in all of them except for tangent and cotangent, we had r. How can we get r? Well, we have this formula. X squared plus y squared equals r squared. It's an identity. It's called the Pythagorean identity, which can also be written as cosine squared of theta plus sine squared of theta equals 1. But in this case, we want to solve for our r so we can get our, it's a missing piece we need to solve for all of our trig functions and their values. So let's plug in our numbers. 4 squared plus negative 9 squared equals r squared. So anything negative raised to an even power is always going to be positive. So we're going to evaluate as 16 plus 81 equals r squared. And recall that anytime we square root something, we get a positive or a negative of it. But since we're talking about radius, which is a distance, it has to be a positive number. So If you add up 1681, get 97, and 97 is that perfect square, so this is our radius. So now we can go ahead and actually do some solving. So let's do cosine first. So cosine of theta equals, remember, x divided by r. So how do we do this? Let's get our x value and plug it in for here. So cosine of theta equals 4 divided by square root of 97. And this is right, but we can rationalize. And all rationalizing really is just timesing by square root the same on the bottom, because mathematicians don't like square roots in the bottom. So once you do that, the trick is it just becomes 4 times the square of 97. We do this because we times, so we have to bring it on top, and this square root, it just goes away. So this becomes your cosine. The cosine of theta equals 4 square root of 4 square root of 97 over 97. This is our cosine. Now our sine, get some more room. So sine of theta equals, it's y over r this time. So y over r. So make sure you have these memorized, but really you just only have to have the 3: cosine, sine, tangent. The rest are just reciprocals. So sine theta equals a -9 over the square root of 97. Now we're going to rationalize, which is just a fancy way of saying getting rid of the square root in the denominator. So we're going to get sine of theta equals -9 square root of 97 all over 97. Now what? Remember what tangent is. Tangent is y over x. Now, I say these are our x and our y because these are terminal points. Now, where's the terminal point? Well, in terms of the unit circle, the point from here, and it can form a triangle depending on where you are, but this has an x and a y value, which is what this is. We don't know what this angle is. It's not in the unit circle 100%, but this is just an example to make you think about it. So this is just our terminal points when we're dealing with like ratios. Now how do we get tangent? So it's y over x. So tangent of theta equals y over x. So we just do tangent of theta equals a -9 over 4. And that's really it. Now the rest of them we can just flip. So cotangent of theta would just be 4 over 9, still negative. And then secant of theta, which is r divided by x. So it would just be square root of 97 all over 4. And then we're going to have room cosecant of theta equal to r divided by y. So that would be the square root of 97 all over -9. So this is cosecant of theta equals this number. But that's how you do it. That's how you find the values of the 6 trigonometric functions with a given angle theta with the x and y, the terminal point of angle theta. So that's how you do it. And they could ask you a question, what quadrant are we in? So with quadrants, the best way to look at it is to do this place right here. So in quadrant 1, remember when we're graphing something like 2, 2. When our x is positive and our y is positive, that means we're in quadrant 1. When our x is negative and our y is positive, we're in quadrant 2. So it's the same logic here. And we can continue on. If we were in quadrant 3, it would be negative 2. If in quadrant 4, our x would be positive, our y would be negative. So looking at our cosine, well, we can tell originally from our points, but let's say we're giving our cosine. If we're given our cosine, look, our cosine is positive and our sine is negative. Of course, which is another way we can find out that our answers are right. Another clue is our tangent is negative. Tangent is only negative in the fourth and in the second quadrant. So it's just a bit of a clue. So if they ask us which quadrant we're in, right now I know exactly. So now let's move on to the next problem. Here, it's similar to the one we just did, but it's also a little different. So they gave us cosine, correct? And they give us cosine, a value of cosine at theta, which is negative 4/9. And they give us sine of theta is greater than 0. So the first thing I recommend doing with these problems is figuring out what quadrant you're in. So when is cosine negative, but sine is greater than 0? Remember, cosine is just another way of saying x most of the time. Actually, all the time. So, yeah, cosine is the x value of the terminal points. Is always two terminal points, x and y. It's the x value of the terminal point, or the x terminal point of theta. Okay, so if cosine of theta equals negative 4/9, sine is greater than 0, that means when is sine greater than 0? Sine is greater than 0 in the first quadrant, because sine is y values. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay? Negative, negative, so these are x. We can just get rid of these. These are possibilities. But cosine and sine are both positive in quadrant 1. So that means the only other quadrant we have is a quadrant 2. So right away we know we're in quadrant 2. Now how do we find the other trig functions? So we have cosine. Well, there's an identity. So, well, we're not in a unit circle. This whole video, we're not in a unit circle, but we can also tell we're not in a unit circle because negative 4/9 is not a cosine that we know. It's not coterminal angles, we'll talk about later. It's something we need a calculator for, or we use triangles. So how can we think about this? So with trigonometric functions, with dealing with triangles, you have SOHCAHTOA. So sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over. This is talking about like the sides of a triangle, and then tangent of theta equals opposite over adjacent. Okay. So if they give us cosine is negative 4/9, we can take this, call this our adjacent, and call this our hypotenuse. There's two ways to do this. You can either plug this into the x squared plus y squared equals r squared and solve for y squared, because if you solve for y squared, then you can have sine, because sine in this case because we're outside of a unit circle, is y divided by r. Because look right here, our cosine, like this r right here, I told you this is the hypotenuse. The hypotenuse is the same as the radius, is greater than 1. So we're nowhere in the unit circle. So we can do what we have here, -4 as our a, and and 9 as our h, or we can recognize that cosine equals x divided by r. Either way, you can do a triangle or you can do this. The hypotenuse is the same as the r and the a is the same value as the x. So we can do -4 divided by 9. So we can plug in -4 for x. So -4 squared plus y squared equals 9 squared. Y squared equals 9 squared minus 4 squared. So 9 squared minus 4 squared. So it's 81 minus 16. And we get squared equals 65. Remember, we're dealing with triangles for the most part. Or you can do this. We have to be positive. So that's the great thing. We have to account for the negative. So square root of 65 is that perfect square, so we can leave it like that. So now we can go ahead and get sine of theta. So sine of theta equals y divided by r, 65 divided by 9. This is sine of theta. Great. Now we can get cosecant of theta, which is just this flipped, which is r divided by y. So we have 9 square root, where's our y? 9 divided by square root of 65. We have to rationalize. So cosecant of theta equals 9 square root of 65 divided by 65. Secant of theta equals r divided by x. So secant theta equals our r was what? Our r was 9. So it's 9 divided by -4. And if you look at it, cosine is -4 over 9, so secant is opposite. So it's 9 divided by -4. So that makes sense. Even here, cosecant, sine, we can prove that they're opposites just by looking at it. If I flip that, I'll have to rationalize. And then tangent of theta equals y divided by x. So tangent of theta equals square root of 65 all over -4. And then cotangent of theta equals x divided by y. It's the reciprocal again. So we have to do -4 all over 65 and do the reciprocal. And like I said, see what the hell's going on? Almost the exact same. So that's how you do it. You could also do it with the triangle. Be a little more work, but just for this part of the video, since it's a part 1, I want to split this video up. I don't want to go into too much length, but I just want to introduce this is a part 1 of a part 2 video, multi-part, because we just talked about just the trig, the value 6 trig functions, and finding them given an ordered pair, find them given which quadrant we're in. But in the next video, we're going to be discussing more triangles and applied problems. Thank you for watching, and if you have any suggestions, leave them in the comments. This is going to be my first video, and I'm going to be starting off with the trigonometry series. I also hope to start with a general chemistry 1 series, but like I said, this is random because it's the start of a new channel. Hope everything goes well, but I do hope to do as much as I can when it comes to STEM. But yeah, hope you have a great day, and thank you so much for watching, and hit that like button and subscribe. See ya.